Hello, I am Manav Ukani from 4th semester Computer Science Engineering PDEU, and we have done this project as a part of our operating system lab. Our topic is disk scheduling algorithm. We have made this project using HTML, JavaScript, and CSS. We used Visual Studio Code Editor and Netlify to deploy this website. This is our home page. Here you can click on the More Information button to learn more about disk scheduling. So what is disk scheduling? Disk scheduling is done by operating system to schedule I/O requests arriving for the disk. The importance of disk scheduling. Since multiple I/O requests may arrive by different process and only one I/O request can be served at a time, thus we need to determine which I/O requests need to wait and which are to be executed. And hard drives are very slow, so we need to do so in an efficient manner. Hence, disk scheduling algorithms are important. Some important terms related to disk scheduling are seek time, rotational latency, transfer time, access time, and disk response time. You can use the nav bar or the quick links below to navigate through the website. And here, if we go back to the home page, if you scroll down, there are cards representing each algorithm. So the first one is FCFS. FCFS is the simplest disk scheduling algorithm. As its name suggests, first come, first serve. The request which arrives first will be first executed, and it's not fast as compared to other algorithm. Let's understand it through an example. If our current head position is at 50 and the request sequence is such as 176, 17, and 34, so we will start from 50 and take the execution as we get the request. So from 50 we go to 176, which is our first request, then second 179, third, fourth, fifth, and so on. And the total time complexity for this algorithm is big O of n, and we can simulate it by clicking on the simulate button. So here we can visualize the whole FCFS. So if we try request sequence like 10, 20, and if we try with negative values or decimals, it will give error since the request track cannot be a decimal or negative number. So here's the error. And if we do it with correct values such as 10, 20, 40, 50, and say the start position is 15, and if we run FCFS, we will get the output, which is total seek time, sequence of execution, that is the order of execution of the request sequence, and the average seek time. And we will also get the graph of the execution, so we can visually see how the algorithm works. And if we go back to home page, our second algorithm is SSDF. SSTF, as its name suggests, shortest seek time first algorithm. In it, we first calculate the seek time for each request, and the request with least seek time will be served. So if we define it in terms of hardware, the requests which are closer to disk head position, the starting position, will be served first. SSTF aims to overcome some of the difficulties faced by FCFS. If we try to understand it through an example, if we have head position at 50 and request sequence such as 176, 17, and 34, and so on. So we start from 50. Now the closest number which is to 50 is 41. So we go to 41. Then number closest to 41 is 34. That is the least seek time. That is 41 minus 34. And so on. We calculate for each request and serve accordingly. So here is the sequence of execution. And the time complexity for this is big O of n square. So we can simulate it in the simulator. So here if we give a input such as 10, 20, 45, 80, 90, and if our initial head position is at say 60, so the closest number to 60 is 45, that is only 15 units of difference, but 60 and 80 has 20 units of difference. So after 60, 45 will be executed. Then between 45 and 20, there is again 15 difference. So then 20 will be executed, and so on. It calculates the least seek time and serves the request sequence accordingly. So here's the graph for the our request sequence, and the sequence of execution is as given. And average seek time and total seek time is also calculated through the algorithm. Now going back to the home page, our third algorithm is the scan algorithm. Scan algorithm, as its name suggests, it scans all the request sequence, and it starts from the starting head position and goes to one of the end of the disk and execute all the requests which come in between. As soon as it reaches the end, it reverses its direction and again starts serving all the requests which comes in between till it reaches the other end, and it continuously does this till all requests are executed. So if we try to understand this through an example, if our head is at 50 and we have request sequence such as 176, 79, 34, 60, 92, 111, 41, 114, then it will start from 50 and move towards one of the end, and then it will, when it reaches the end, it will reverse its direction and move towards the other end. So the time complexity of this algorithm is big O of n log n, and we can simulate it through navbar also. Instead of clicking the simulate button, we can go to navbar and select any of the algorithm which we want to simulate. So scan. So here if we put request sequence such as 10, 20, 35, 40, 55, and initial head position as 15, and we can also select the direction in scan if we want to go to the left end or right end first. So this direction determines which direction we go initially. So here we have chose left. So first we will go to the left end, that is towards 0, and then we will move towards right. So our sequence of execution is 15, 10, 0, 20, 35, 40, 55. Average seek time is 11.67. Next algorithm is CSCAN. CSCAN stands for circular scan. It's a modified version of scan, and it deals with the inefficiency involved in scan algorithm. Here the head moves from one end to other end and serves all the requests in between, and when it reaches one end, it reverses its direction. But unlike scan, it does not serve all the requests in between. It directly comes to the another end, and then from that end it starts moving and serves all the requests. Here's an example. Here we can observe that the requests are served in going from one end to another, but it returns back without serving any request, and as soon as it reaches the other end, it starts serving the request again. And the time complexity for this one is as well n log n. So we can simulate it by clicking on simulate, and here we can try some request sequence input like 10, 20, 35, 50, 80, 70, and say the initial head position is at 60, and this time we try the right direction, so it will go to the upper side, that is 199 first. So run scan. So here we can see that it goes towards the right direction first and then comes to the 0. So this is our visualization, and total seek time is 388, and sequence of execution is as given. Coming back to the home page, our next algorithm is look algorithm. So look is a modified version of scan. Unlike scan, it does not go till the end of the disk, but it just goes to the end of the request. That is, it serves till the last request only. So here, for example, our start is from 50 and the request sequence is as given here. That is 176, 79, 34, 60, 92, 11, 41, and 114. So we start from 50 and start moving towards the right direction, and we just go to the last request, that is 176 in the look algorithm. But if it would be scan, we have to go till 199. So there is some time saved in look, and then we go back serving other requests and by reversing the direction. That is same as scan. There's no difference, but the main difference is that it only goes till the last request and not till the end of the disk. And here also time complexity is big O of n log n. So if we simulate it, we can get a better understanding. And if we try to put a value which is larger than our track sequence, like a maximum is 200, so if we try to go beyond it, we will also get an error saying that you have run beyond the range. So we have to be in the range, and if we try to run this using the loop, we get our output and the request sequence. Here you can see that we don't have to go till the end, that is, we don't have to go till 0 or 200. We just have to be in the between the maximum value, that is 90, and the minimum, that is the 10. So we can simulate the look algorithm by using values such as 10, 20, 30, 40. And if we go beyond the limit, there we will also get an error saying that you have to be in the range. Integral value should be in the range. So if we stay in the range and try to execute this, we will get the output. That is, first we will start from head position, that is 50. Then we will move towards the left side since the direction is left. So we move towards the left, that is 40, 30, 20, 10, and then after that when we reach the end, we go back to 120. So sequence of execution will be like this. And here you can see that we don't have to go to till the end of the disk, that is, we don't have to go till 0 or 200. We just have to go till the last request sequence and the uppermost request sequence. Next algorithm is the CLOOK algorithm. CLOOK algorithm stands for circular look, and it's a slight modification of the look algorithm. In this, the DISCOM moves and services each request till the head reaches its highest request, and after that DISCOM jumps to the lowest request without serving any request in between. But in look, we observed that the request in between were served. Here you can see the example. The request in between are not served when we jump from highest to lowest, and again we start serving the request. And the time complexity is big of n log n. So if we simulate this and input values such as 10, 20, 30, 50, 60, 75, 90, and say our initial head position is at 40, and this time we choose the right direction. And if we run clook, we can observe that it goes to the right direction, that is the upper values. So from 40 it goes to 50, 60, 75, 90, then comes back directly to the lowest value, that is 10, and then from 10 it again starts serving the other request. If we come back to home page, you can see there is this one button saying comparison of algorithm. This is our X factor that we have added. So if we click on the comparison of algorithm and we put the request sequence, say the initial head position is at 55, and if we click on compare, then we can see all the different algorithms in a single graph, and we can also see the total seek time for each algorithm. So we can select the algorithm having the minimum seek time. So here minimum seek time is for both SSTF and look, so both are equally efficient. So this is the X factor that we added to easily compare which algorithm is working the best for a given case. And if you go to the navbar, you would notice about us button. So here about us, this website was developed as a part of operating system labs in the fourth semester of computer science engineering. We are the students of PDEU, and we have done this project under the guidance of Rutved sir. And you can see the everyone who has contributed to this project on the about us page. Thank you.